Hello. Looky there, the derivative function. This chapter, of course, is based off of the derivative function. In the entire first section, we didn't even use the word. Well, here we are. And those of you who read ahead of the speed at which I speak, which is pretty slow, you may have noticed that guy right there looks awfully familiar. Isn't that guy right there the same as the slope of the tangent line? It is. And here I am saying that the derivative is also that, which, if that is the slope of the tangent line, and if that is the derivative, then that must mean the derivative is the slope of the tangent line. Remember at the beginning of the first section of this chapter, I said that? Derivative meant slope. Well, here we are. So we can now replace the phrase slope of the tangent line with the word derivative. We denote derivative by putting this little apostrophe here that we will call prime. So if I ask you to find f prime of x, or f prime, or y prime, or whatever, that's just me simply saying find the derivative. Use the slope of the tangent line formula to find the derivative with respect to x. Now, what we did yesterday at the very beginning of the lesson, and when I say yesterday, I meant in the previous lesson, I had you substituting in x values at the end to get an actual number. Not so much anymore. That's still going to happen. But just as often as not, I'm just going to ask you to find the derivative with respect to x, which means at the end of the problem, we will not be substituting a number in. Our answer is going to have x in the answer. Redundant. So let's do it. So there's f of x. I need to use that formula right there to find out the derivative, to find f of x, f prime of x, pardon me. So I know what f of x is. No need for me to repeat it. F of x plus h is going to be the same as 2 times x plus h, which is the same as 2x plus 2h. And it's supposed to be an h there. Let me see if I can make that look okay. That looks okay. Very difficult writing on these touch screens. Life is hard enough. So let's substitute what we know into that formula right there. The derivative is going to be f prime, and f prime of x is going to equal the limit as h approaches 0 of f of x plus h, which is 2x plus 2h, minus f of x, which is 2x. That's going to be all over h. Well, as some of you may have noticed, and I'm going to kind of be a little lazy here because I don't have that much space. That parentheses is useless, so let's get rid of that. That parentheses is also useless, so let's get rid of that. And that parentheses is also useless, so let's get rid of that. And that parentheses is also useless, so let's get rid of that. Okay. All I did was got rid of parentheses. There's no distributing the negative that we have to worry about for f of x. So that's good. Oh, look, a 2x. Oh, look, a 2x. That's negative. That leaves me with 2h over h. Oh, look, h's that cancel out. So that would leave me with the limit as h approaches 0 of 2, which is just 2. And so my answer is 2. Nothing to plug in for x? Heck. There's not even an x to plug in. So the answer is 2. So f prime of x, in the end, if I wanted to rewrite this out and clean this up and make this look a whole lot better, f prime of x equals 2. That's the derivative. The same exact thing that we learned last section. Yester section. Created a new word. Ring-a-ding-ding, Merriam-Webster, I have a new word for you. Ring-a-ding-ding, ring-a-doo-doo-doo, the office.
All right, let's do a couple more find the derivative of problems. So let me remind you that now we know the derivative is the same thing as the slope of the tangent line, which is the limit as h approaches 0 of f of x plus h minus f of x over h. We now know that. So if y equals that, oh, we haven't dealt with y. Is that going to change things? No. I'm still going to call this f of x plus h. And I'm just going to make believe that that's f of x. No big deal. F of x plus h, or we could also say y of x plus h, is going to be 3 times x plus 2, x plus h squared. Remember, x plus h squared is the same thing as x squared plus 2xh plus h squared. And so distributing the 3 through all of that, you get 3x squared plus 6xh plus 3h squared. So the derivative, which we'll call y prime, is going to equal f of x plus h, which ended up being 3x squared plus 6xh plus 3h squared, minus f of x, which is parentheses 3x squared, but since there's no distributing the negative here, I'm just going to write out 3x squared all over h. Oh, I forgot to write out what the limit was. So the limit as h approaches 0. Squeeze that in. Very easy to forget that, but you should never not write it out, even though it's easy to forget. These go away. There's an h in common with all three of them, so let's just do that right now. The limit as h approaches 0 of h, bring out an h, 6x, 3h, h. So limit as h approaches 0 of 6x plus 3h. If I plug in 0 for h, I get 6x plus 3 times 0, which is 6x. So since I'm answering with respect to x, I'm going to leave x in my answer. Although we said that in the last problem that that's what you're supposed to do, it didn't appear that way because there was no leftover x. Well, now we do have a leftover x. So my final answer is going to look like y prime equals 6x. We had a lot of success finding out 6x. Ah ha 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 ha. Ah ha 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 ha. Oh, boy. This pandemic has not been good for my brain. Great for my brand, though. You can probably hear in the background my children screaming. Oh, they are just angels. They are just angels, all 4 of them. What was I thinking? Anyway, find the derivative with respect to x of f of x equals x cubed plus 3. This is not going to be pretty. Hopefully I have enough space. Let's worry about what f of x plus h is. This is not going to be the fun part. You ready? And here's why. Because I'm going to replace every x cubed, or x rather, with x plus h. So that is a cubic, which we haven't done yet. Gross. My part's not going to be so bad. So in case you forgot, and I'll write it up here so I've saved myself some room. If you have x plus h cubed, that's the same as x plus h times x plus h times x plus h. Well, we already know what that guy equals. We already know what that guy equals because we just did that up here. So f of x plus h is going to equal x squared plus 2xh plus h squared times x plus h plus x plus h. Now what I do is I foil. Or in this case, there's a lot more outers and inners to deal with. So I'm going to foil. I get, let me see. I get x cubed plus x squared h plus 2x squared h. That's going to simplify. Plus 2xh squared plus 2 plus h squared x. It's going to simplify. Plus h cubed plus x plus h. Mm-hmm. These guys combine x cubed plus 3x squared h. These guys combine 3xh squared plus h cubed plus x plus h. And looking at that, I don't see anything else simplifying. So, hopefully we have enough space. If not, we can force it. Space force it. The limit as h approaches 0 of f of x is that monster. X cubed plus 3x squared h plus 3xh squared plus h cubed plus x plus h minus f of x, which was x cubed plus x. All over h. First parentheses aren't useless. Second parentheses, I have to distribute the negatives, so I end up getting x cubed plus 3x squared h plus 3xh squared plus h cubed plus x minus x cubed minus x over h. And as usual, things will go away. And things will go away. And as usual, you should be able to find h's in common with the majority of the remaining things, in this case, all of them. So there's an h up top, there's an h up top, there's an h up top, and there's an h up top. There's 4 things that we can bring an h out of. So let's do it. Pull the h out of 3x squared h, leaving us with just 3x squared. Pull the h out of 3xh squared, which leaves us with just 3xh. Pull an h out of h cubed, which is h squared. Pull an h out of h does not make 0, but instead 1. Over h. Boom. The limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 1 is going to force these guys to go away because they become 0. And so I am left with 3x squared plus 1. So in the end, f prime of x is 3x squared plus 1. Don't plug in anything for x. You don't need to. All right, once again, we're being asked to find the derivative with respect to x. So let's remind ourselves that the derivative is the same thing as the limit as h approaches 0 of f of x plus h minus f of x over h. Now, I'm going to be a little creative knowing what I know when I begin this one. Instead of calling it f of x, I'm going to call it g of x. So g of x plus h is going to look like this. And I'm not going to foil that out. Not yet. Maybe I will. Maybe it would be useful, but I don't think that I'm quite there. Maybe. We'll see. So the limit as h approaches 0 of g of x plus h is going to be 2 over x plus h in parentheses squared, leave a little space, minus f of x, g of x, which is 2 over x squared. It's going to be all over h. In order to combine these guys, I need to multiply u by x squared over x squared. I need to multiply u by x plus h squared over x plus h squared. All right. And that's going to give me the limit as h approaches 0 of 2x squared minus 2x plus h squared over x plus h squared over h. X squared. I knew I forgot something. I forgot two things. Ugh. Ugh. Watch what I do. And this is, of course, me taking some of the stuff that I learned from Algebra 2. I'm going to bring a 2 out of this guy. But you know, before I even do that, let me kill two birds with one stone. First, I'm going to pull the 2 out of this guy. Bringing a 2 out, that leaves me with x squared minus x plus h squared. All right. I have x plus h squared, x squared. Watch what else I do while I do that. That's going to be h over 1. So what I need to do is multiply the top and the bottom by 1 over h, 1 over h, and that's just going to throw another h down here. Now, what I have inside this parentheses is something squared minus something squared, which is a difference of squares. So I'm going to factor that out. Now, this might be helpful, maybe, maybe not. I don't know. We'll see. This is just how I'm approaching this problem. Some of you might want to FOIL the whole thing out, but I'm just being a little cute here. What I do best. All right, so I have, let me make this bracket. A square minus a square means I have the square root of it, in parentheses, plus the square root of that, times the square root of that minus the square root of that. And that's going to be all over x plus h squared h. That cancels that. Well, let me move it all the way over here. Can you guys see that? Yes, you can. Yes, you can. Low limit as h approaches 0 of 2 bracket parentheses x plus h is 2x plus h. X minus h is h. Over. And watch how I write this out. Watch me being cute again. No. Oh, bummer. Oh, bummer. Wait a minute. Yeah, that goes away. That should be negative h. So I have x plus h squared, x squared, h. The h's cancel out. At this point, I can actually plug in 0 for h because it won't turn the bottom 0. So I'm going to do that. 2 bracket 2x plus 0 over x plus 0 squared x squared. And that's a negative h, so I keep forgetting about that negative. I have to bring that negative out. Shame on me. That ends up being negative 2 times 2x over x squared times x squared. Negative 4x over x to the fourth is going to be negative 4 over x cubed. So not pleasant at all. And that's just the way I handled this problem. Okay? That's how I handled this problem. That is correct. And it looks like, wow, all that. I don't think you did it right. No, I did it right. I just did it differently. And unfortunately, the next problem could be just as challenging, I think. Just as challenging. We'll see. We will see. I'm just going to call these f of x. So you're f of x now. F of x plus h is going to equal the square root of x plus h squared minus 4. Which is the same as the square root of x squared plus 2xh plus h squared minus 4. So the derivative is going to be f of x plus h, which is root x squared plus 2xh plus h squared minus 4, minus f of x, which is root x squared minus 4 over h. We're going to do that rationalizing the function thing again, where we're just going to multiply the top and the bottom by this exact thing, but we're going to throw a multiple or an addition sign in between. So I have x squared plus 2xh plus h squared minus 4 plus root x squared minus 4. Multiply that to root x squared plus 2xh plus h squared minus 4 plus root x squared minus 4. That's going to equal the limit as h approaches 0 of that. And keep in mind, we're foiling here. That guy times that guy, which just turns into a regular thing. X squared plus 2xh plus h squared minus 4. Remember, when you do the rationalizing the function, the outer and the inner disappear, and you're going to end up with minus x squared minus 4. Because you're taking the square root times the square root, which is square root squared, they disappear. That's going to be over, unfortunately. H, and I'm just going to leave it like this again. I have a feeling, just kind of like up here, that if I just factor the h through everything, which won't make a difference because I can't multiply the h to the inside, it's just not going to help. So I'm going to leave the h on the outside. I have root x squared plus 2xh plus h squared minus 4 plus root x squared minus 4. That ends up being, drop the parentheses, x squared minus x squared is going to go away. If I distribute the negative, that becomes a plus 4, so that goes away. So I'm left with 2xh plus h squared over that. So I'm going to say 2 times ugly. H times ugly. Sorry, H times ugly. And I'll bring ugly back. I just did not have a whole space to put it. We're bringing ugly back. Justin Timberlake. If you take the top part, notice that you can bring an h out. I have 2x plus h, regular h, over h times that ugly. So let's bring the ugly back. Square root of x squared plus 2xh plus h squared minus 4 plus the square root of x squared minus 4. I can now cancel out the h's, and I can now plug in 0, and 0 won't make the whole thing go away. So if I plug in the 0 for h, u disappear, u disappear, u disappear, and that leaves us with 2x on top. The h is gone, so I have the square root of x squared minus 4 plus the square root of x squared minus 4. Oh, that's two of them. So that leaves me with 2x over 2x squared minus 4s. The 2's cancel out. And so at the end of the day, y prime is going to equal x over the square root of x squared minus 4. Now I know what you're thinking. Why did I take this class? What am I doing with my life? In the next section, we're going to do the shortcuts. And what I was doing in that brief pause is I was doing the shortcut in my head to make sure that I did it right. So I know how to do this problem in seconds. I know how to do this problem in seconds. And you might be thinking, whoa, 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 the heck? Why are you doing this to us? Well, I mean, and sometimes you just have to appreciate the climb. I believe it was Miley Cyrus who taught us that. You have to appreciate the climb. It's the climb. Now, the rest of the class isn't going to be near as brutal as the two problems we just did. Not even close. Let's look over some of the derivative facts that we know. And we'll do a few more problems, and then that'll close out this section. As I said at the very beginning, the derivative is the slope of the tangent line. We already know that. We already know that. Here's a picture. Here's our roller coaster. The tangent line represents what your roller coaster car looks like at that given moment. The equation of the slope of the tangent line, it looks an awful lot like point slope form. You might remember point slope form as y minus y sub 1 equals m times the quantity x minus x sub 1. Well, instead of m, we're saying the derivative. Well, after we take the derivative, we'll plug in whatever x value we have. That's what this guy says. And instead of saying y, we're saying f of x. So if you're wondering, that looks awful. I've never seen that before. You have. And in fact, when we do those problems, I'll probably write that out because it's more pleasant to look at than that guy. But they mean the same thing. They mean the exact same thing. It's just more often than not, you won't be given the y value. You'll have to find the y value on your own. And that's why we take the derivative, because if I just gave you a bunch of points, you could just use that. Well, no, I'm just going to give you a function. I'm going to ask you to find the slope of the tangent line at that point and give me the equation to it. So I will reference the top guy there, knowing very well that it means the same as the bottom guy there. A function is not differentiable. Now, what does differential mean? Differentiable means you can take the derivative. Okay, a function is differentiable if you can take the derivative. Taking the derivative is also called differentiation. Okay, so if you hear me throw that word out, and again, talking and writing at the same time is certainly not a strength of mine. If you hear me throw that word out, if you hear me call differentiation or this is differentiable, it just means that I can take the derivative of it. It's just the same exact thing. We will learn something in a few lessons called implicit differentiation. This is technically called explicit differentiation. I just don't want to call it that because, I don't want to get banned from YouTube for using explicit language. Anyway, if the limit of the point does not exist, you can't take the derivative if you can't take the limit, clearly, because the derivative is taking the limit.
4 is easy. If you don't feel like putting the of x, you don't have to. You can also refer to the derivative as d dx or dy dx. So if I gave you y equals something, if I ask you to find dy dx, what that means is take the derivative of y with respect to x. The derivative of y with respect to x. And if I say, and so I could write that out as saying d dx. And so you might be wondering, oh, well, d dx times y is the same thing as that. It kind of all works out. It all makes sense. Speaking of making sense, you may have noticed from problems like this guy, that answer ended up being 6x. This answer ended up being 3x squared plus 1. A quadratic with a degree of 2 turned linear with a degree of 1. A cubic with a degree of 3 turned into a quadratic with a degree of 2. Going back to this one, which I actually have written down, a linear with a degree of 1 turned constant with a degree of 2. If I take the derivative of a polynomial, it knocks its degree down by 1. Okay, cubics turn into quadratics, quintics turn into quartics, linears turn into constants. It drops down the polynomial's degree by 1. So those are a bunch of rules that might be useful as we continue, as we press forward.
All right, so we're going to, in this problem, let f of 2 be 5 and f prime of 2 equal 20. And it's asking us here to find the equation of the tangent line y at x equals 2. So it's actually just giving us everything in the form that I said was terrible. So I'm going to write that out. Y minus f of x sub 0 equals f prime of x sub 0 times x minus x sub 0. Lots of x sub 0s. Okay. X sub 0 is 2. So f of x sub 0 is going to be f of 2, which is 5. So let's just plug it all in. Y. Oh, by the way, this is supposed to be f prime of x sub 0. So f prime of 2 is 20. So let's plug it all in. Y minus f of x sub 0 is the same as f of 2, which is 5. Y minus 5 equals f prime of x sub 0 is the same thing as f prime of 2, which is 20, times x minus x sub 0, which is 2, and I'm done. So that example was just, okay, take that ugly, 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 terrible looking monster equation and plug stuff in, and I did. And I did just fine. My job is to find x, or f of x, f prime of x, and the slope of the tangent line at x equals a. Now, this is not the equation of the tangent line, which is what we just did in the last problem. So not only am I finding the derivative, at the end, I'm plugging in whatever that guy is right there. Right? So I know, and we talked about shortcuts, I know that that's going to be 8x. Now, how do I know that? I don't know. But let's find out. The limit as h approaches 0 of f of x plus h. You know what I forgot to do? I never found f of x plus h. So let's do that up here where I have the space. This guy, f of x plus h, is the same as 4 times x plus h, which is the same as 4 times x squared plus 2xh plus h squared. I really should use pencil, which turns into 4 times, oh my gosh, 4x squared plus 8xh plus 4h squared. Terrible. 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 So the limit as h approaches 0 of f of x plus h is 4x squared plus 8xh plus 4h squared minus f of x, which is that. So we see things canceling out over h. These guys go away. While I'm at it, let's bring an h out. So I have the limit as h approaches 0. Bring an h out. hx plus 4h squared over h regular h. Sorry, 4h club. Cross out the h's. And that equals the limit as h approaches 0 of 8x plus 4h, which just becomes 8x. Now my derivative, so what that means is my derivative, my f prime of x is equal to 8x. What's my slope of the tangent line going to be? Well, just plug in 2 because it tells me to plug in 2. So my slope of the tangent line at 2 is 16. I could have sworn we've done this one already, but we must not have. Maybe in the previous section we did. I don't know. No big deal. No big whoop. No big whoop. F of x plus h is going to equal 1 over h plus x plus h squared. I'm going to leave it like that just for now. It may not be necessary that I leave it like that, but I'm just going to leave it like that. So the limit as h approaches 0 of f of x plus h minus f of x over h let's multiply the top and the bottom of this guy by x squared over x squared. Let's multiply the top and the bottom of this guy by x plus h squared over x plus h squared. And that ends up being the limit as h approaches 0 of x squared minus x plus h squared all over x plus h squared times x squared all over h over 1. We did do this one. Multiply this by 1 over h, 1 over h. The cute way that I did this one is I turned that into a difference of squares problem. So this is the same as x minus x plus h times x plus h over x plus h squared x squared h. And let's not forget the limit as h approaches 0. Simplifying the top, I have x minus h makes the x's go away. X minus h makes the x's go away. X plus h turns that into 2x plus h over x plus h squared x squared h. These h's cancel out. Now I can plug in 0 because it won't make the whole thing 0. So I have 2x plus 0 on top, and on the bottom I have x plus 0 squared times x squared. Turns that into x, 2x over x squared, which is x to the fourth, which turns that into 2 over x cubed. And you know what? This whole time I forgot about the negative h. That should have been a negative h, which means you're negative, which means you're negative, which means you're negative, which means you're negative. So my derivative My f prime of x is negative 2 over x cubed. My slope of the tangent line is going to be when I plug in 3. 3 to the third power is 27. To end the day, we're just going to just take the old tried and true derivative. Dy dx is going to be f of x plus h. So f of x plus h is going to, in this case, be 2 times x plus h squared, which is the same thing as 2x plus 2h plus x squared plus 2xh plus h squared. So dy dx is the limit as h approaches 0 of f of x plus h, which is 2x plus 2h plus h squared plus 2xh plus h squared, minus all of f of x, so I get minus 2x minus x squared over h. You're expecting things to disappear, like that guy, and like that guy. And so you have an h, an h, and an h over an h, so bring the h out. That leaves us with 2 plus 2x plus h over h. Cross out the h's. Plug in the 0 for h, and I get 2 plus 2x. That is what dy dx is. F of x plus h is 1 over root x plus h. So dy dx, the derivative, is f of x plus h minus f of x over h. Let's rationalize that function by multiplying the top and the bottom of this one by, well, not yet. I'm sorry, not yet. I apologize. Let's get rid of that parentheses. Let's multiply this one by root x. Let's multiply this one by root x plus h, root x plus h. And that's going to give us root x minus root x plus h over root x times root x plus h. And that's going to all be over h. That is the same thing as, let's kill 2 birds with 1 stone here. Let's multiply that by 1 over h, 1 over h. So you go away. I have h on the bottom, the limit as h approaches 0 on the bottom, times, you can multiply 2 roots together and multiply the things on the inside, so that happens. And this gives me x minus x plus h. Didn't leave myself near enough space, so let's just add paper to it. Now I'm going to rationalize the function. And the way I do that is I'm going to multiply the top by root x plus h over root x plus h. And let's move that down here where I have a little bit more space. The limit as x approaches 0 of root x times root x is x. If you're doing the rationalizing the function thing, the o and the I kill each other off. And that turns into minus x plus h. So that's good news. Over h times, and I'm not gonna bother doing anything. Root x squared plus xh times root x plus root x plus h. X minus x goes away, negative h is left over h, that's nice. That becomes x squared plus xh under the root. That, oh, not yet, we're not there yet. Root x plus h. Now I can plug in my 0. So now I can cross u out and cross u out. And so I am left with a negative 1 on top, a negative x squared, a regular x squared on the bottom, times x plus x in roots. Negative 1 over root x squared times 2 root x. Oh, that just becomes x. Is negative 1 over 2x root x. And that is by dx. Gross.
Well, ending a wacky problem in a wacky day is not so bad, because the next lesson, I give you shortcuts to do all of these, and life is going to be so much easier. Mean. But that'll do it. Another long lesson, another doozy. Okay, bye.